Welcome everyone to week two of environmental science on hybrid learning. Um, just a fair warning, you guys, this video is gonna be a little bit lengthy. I'm gonna try to keep it under 20 minutes though, so we can get through it pretty quickly, pretty easily. This will also be made into an ed puzzle that you guys have probably already seen. Um, but let's get it going. So today, guys, we're going to talk about observations and inferences. Last week, you guys went outside and took some observations by yourself, and we wrote down some qualitative, we wrote down some quantitative. I actually went through all of those last night and read them, and we're missing the mark just by a little bit. So I have some examples on here we're going to look at. I also want to just give you guys a brief refresher what it means to make actual observations, and then be able to differentiate what an inference is. So if you have questions about these notes, guys, when we're done, please reach out to me. Please ask me. Please let me know. But as of now, let's get a roll. So observations and inferences. First thing, making a good observations comes down to two pieces. Either you have qualitative or you have quantitative. Qualitative is based off of qualities that we observe. So use your five senses. So think of things like color, shape, size. Okay. Now, quantitative is based off of measurements that we observe. So it's the quantity. It's going to be a numerical number. Um, Now, with this being said, we don't always carry around, say, a ruler. So, like I told you guys before, that we can use quantitative observations, say, as like how many fingers it takes, or how many hands tall it is, or relatively, I'm 6'2", so the bush I'm next to is roughly 6 feet because I'm a little bit taller than it. You can use relative size to make those measurements, okay? Or you can just basically count. What I want you guys to do is understand that quantitative is good and qualitative is also good. But the mark that we're missing is that this has to be factual. So there cannot be any what ifs. If I tell you that this water bottle, or we'll use this flower, if this flower is yellow, you can't argue with me and say that this flower is red. No, it is yellow. Okay? Is that clear? Qualitative observations. Now, can we combine these two things? The answer is yes. So I'm sure some of you guys have ever been to the doctor for an injury, you don't feel good or anything like that, and the doctor asks you, how good do you feel on a scale of 1 to 10? Now, when you're 7 years old, you don't know exactly what the 1 to 10 scale is, but instead you know these photos. So these numbers are your quantitative, they're your quantities. These pictures are your qualitative observations. So if you go to the doctor, you're like, I kind of feel like this guy right here. Okay. The doctor will be like, okay, I know you're about a 6 then. So in the computer, he can type in the 6 rather than saying he feels, eh. Okay? It gives us a numerical value off of your qualitative observation or your qualitative feeling. Okay. This is just a scale that we can use. Can we use scales like this in observations? Yes. Okay. We for sure can. Okay. And we will work on that throughout this trimester. Now, what is an inference? A lot of you guys have already started doing this, but you guys didn't know what it is. So, an inference is an explanation for an observation you have made. They are based on your past experiences and prior knowledge. And they often can change when new observations are made. So, an inference, guys, is going to be based off of your observations. And as you get older and as you gain more knowledge, your inferences can change, and that's totally okay. So, like, my inferences will be different than your inferences based on the knowledge that I have and based off the knowledge that you have. Okay, not saying I know more than you, because there can be a lot of topics that you know a lot more than me, so your inferences are going to be a lot different compared to mine. Okay, so we're going to go through a couple of these examples. So you can be like, oh, okay, that's where the inference is. There's observations, but there's the inferences. And I know I think I have like 7 of these examples. I'm not going to go through all of them because it'll get very long and tedious, but I'm going to go through a couple with you just so you guys can see and understand what I'm talking about. So example number 1, I'm just going to read it and then we'll try to break down what are some inferences and what are some observations. So organism 2 is around 10 inches tall. It has gray fluffy fur and a white underbelly. It has 4 legs. It lives in trees mainly looking for food there. It puts food in its mouth to bring back to its nest. So let's decipher this and break this down just a little bit. Around 10 inches tall. Is that a qualitative or quantitative observation? If your answer was quantitative, you are correct. It is a quantity. Now, do they know exactly if it's 10 inches tall? No, but could they make a good guess? Probably yeah. It has a gray fluffy fur. It has gray fluffy fur and a white underbelly. That's also a good observation. It has four legs. That's also a good observation. You cannot argue with people on those aspects. It lives in trees mainly looking for food there. Now, this is where the problem is. Do you know exactly why that squirrel is in that tree? Or why this organism is in this tree? I'm just taking off it's a squirrel. I apologize. But do you know exactly why this organism is in the tree? Your answer should be no. You do not know exactly. So they're making a judgment or they're making an inference saying that's what they're doing, is that they're looking for food. Now, the next sentence says it puts food in its mouth to bring back to its nest. Now, do we know that that food is going back to its nest? No. Especially during this time of the year when there's not babies, who knows if it's going to its nest? Okay. So those are inferences. Did they start off strong with two observations? Or three observations? Yes. Did they end with two inferences? Yeah. Okay. So that's where the issues come in. Make sure that you only have observations when asked for observations. If you want to add inferences, make sure that you're getting inferences because I'm asking for them. For the next example. Next example says a tall, stately organism, roughly 20 feet in height. The first 6 feet are bare, covered only with bark. The midsection of roughly 10 feet is covered with palmate leaves and branches before reaching the last 4 feet of the structure, which is bare due to disease. Guys, I'm going to pause the video and I'm going to ask a question. What part of this is an inference? If your answer was, which is bare due to disease, you are correct. Okay? Guys, the tree could definitely be bare. You're not wrong there. But do we know if it's from disease or not? No. Okay? Because we do not know exactly what the health of that tree is. Could it have been plucked or could it have been dead from something else? Yes, it's possible. Now, could you make a very good judgment saying that it is from disease? Yes. But that judgment then becomes an opinion, which then becomes an inference, and it's not exactly factual, so it cannot be an observation. Oh, let's, okay. Does that kind of make sense there? The next one. Bushy tailed, climbs trees, has a puffed out mouth, tiny ears, whiskers, white belly, soft looking, 4 fingers, long black nails, body is 9 inches long. This right here are all observations. The only thing that is not a perfect observation is this one right here. Tiny ears. Guys, what about that do I not like? If your idea that you're thinking in your head right now is the word tiny, you are correct. Tiny, guys, is a descriptive word. I agree. But my definition of tiny and your definition of tiny can be two different things, which then categorizes and breaks up the opinion from the fact and kind of ruins your observation. Okay? Now, I'm going to skip down to this last one, okay? Because I want to go through this one with you. If you guys feel like going through the other observations, this thing will be there for you guys to look at. But I do want to just go over this last one with you to kind of talk about it. So it says the first organism is a plant which contains the colors of yellow and green. The organism has a tall stem that is slightly over a foot tall. The color green would describe the leaves that go around the stem, and the yellow color would describe the main part of the plant, which is also almost flower-like. The main part of the plant is very small, so there are So there are multiple of them crowded together to form one large section of the plant. Those are near the top of the stem, while the leaves are in the middle of the plant. The plant seems to be wet from rain, as the flower-looking parts are shriveled up. The plant still seems healthy, but does not seem like it had been freshly grown recently. Okay, I want you guys to understand this right here is getting better to the closer, or it's getting closer to the expectations I have for all of you. Okay, this is really well worded and it paints a good picture of what she is looking at or what he is looking at. Now, there are a couple of problems in here. Okay, I want you guys to look at this. I want you guys to write down what part of this you think she is missing or he is missing. What part of this is actually an inference? Take a break. Now, If you said that the parts that you think are missing are they're wet from rain, the parts are the flower parts are shriveled up. This is this is an observation here. Shriveled up is observation, but wet from rain is an inference. You don't know if it's wet from the rain. The plant still seems healthy, also not an observation. That is an inference, but does not seem like I've been freshly grown recently. This is also an inference. Okay, but what I want you guys to do, read back through this, understand that this person spent a lot of time looking at this one observation or this one organism and was able to actually depict this in a way that made sense to everybody. Okay. Now, guys, I know it's pretty brief, that's pretty quick, but I want you guys to understand we're going to be doing this again. If you're one of your choices not get picked in this list, it does not mean it was not good, or does not mean that it was not bad, or that it was really good, or anything like that. I just went through a couple. I just took the ones I think that I liked to use for these observations, okay, or for this thing. But make sure you guys still understand qualitative is the quality, quantitative is the quantity, and it must be factual. And understand that inferences are there. Now, last thing we're going to talk about, guys, is not even based off of this. I'll just bring it to this slide. What you guys need to know, what you guys need to understand, in our daily lives, when we make observations, we typically make inferences automatically. Now, that's why it becomes difficult when I ask you just to make an observation or if I tell you just to make an inference. Because our body usually, or our mind usually does them both together. Okay? They're conjoined, they work together. Your inferences are based off your observations. Now, what I want you guys to practice, if I ask for observations, just give me the observation. When I ask for an inference, just give me the inference. Now, the last I'm going to say to you, when you make inferences, make sure they are correlated to the observation. Okay? If they're not correlated to the observation, this is where we run the problems. If you told me that this flower looks dead, that's great. That is an inference. But if there's no observation saying that it's crunchy, that it's shriveled, um, that it's not in water, anything like that, then your observations do not match your inference. Now, we're going to talk about this more and more every day, at least for the first week. Okay. So, if you guys have any questions, concerns, issues, please reach out to me. Talk to me. Other than that, have a good day, guys.